Hi everyone, and welcome to a new video on my channel. This time the video is accompanying a previous blog post that I wrote, but also an accompanying video that I recorded. You can see it here. That's the blog post that deploys AKS with Nginx, external DNS, Helm operator, and Flux. And if you didn't follow that, if you didn't read that blog post or looked at the video, I recommend to do so to understand what we're going to do in this video. So in that blog post, we actually discussed a pipeline that's run to deploy AKS together with all kinds of components like Nginx, like external DNS, like Flux, Cert Manager, etc. And that makes it easier. In my case, when I do demos, makes it easier to run applications on the cluster, have them immediately accessible on a URL with certificates and so on, the way it's supposed to happen. As I said, to deploy the applications, as I said in the previous video, to deploy the applications, I don't want to use the pipeline. I want to use configuration in a Git repository, and Flux is the software that actually reads that repository and then configures the cluster accordingly. Let's look at the repository. So this is a public GitHub repo that contains my config. Where you deploy or where you put your YAML files and your config files, that's not important. Flux will look at all of them. Can be configured otherwise, but in this case it's done that way. I'm going to focus on two things. I'm going to focus on an application called Real-Time. I'll show you in a moment what that's about. And that application also will need certificates, and we have to configure Cert Manager with cluster issuers, in this case for Let's Encrypt. We'll see later how that works. But we first have to link our cluster to this repository, and that's something which is done by configuring Flux. Now that could be automated. I didn't automate that, so I have to run a couple of commands to do this properly. Now I aliased kubectl with k, so I'm going to do k get po to check if there are pods running in the default namespace, and yes, I use the default namespace. It's a demo, no worries. And if I'm checking the namespace kube system, you will see that I have Nginx deployed. By the way, I installed the crew plugin to switch namespaces. If you want to know how that works, search for crew with a K, K-R-E-W, and that one allows you to install all kinds of kubectl plugins. In this case, one to switch namespaces and set that namespace as the default. Let's do a k get po as well here. And what you see is I have I have Nginx running here. My Nginx ingress controller is running, and my external DNS is running as well, running properly, which is perfect. If I switch namespace to Flux CD, and I look at the pods in Flux CD, Flux is running there plus the Helm operator. If I switch to the namespace Cert Manager and I ask for the pods, I have Cert Manager running there as well. So everything is ready for me to deploy applications that depend on all of these components. Yeah, and again, we install these components in the previous video. Go and look at that one to see how that is done. Good. Now I want to link my Git repo to Flux. How do we do that? Well, there's a command line tool you can install, which is fluxctl. I already installed that. To install it, just Google Flux and fluxctl. You'll find how to install it. It's just an executable you have to download and put in your path. And in this case, with fluxctl, there is a identity. Actually, I'll clear the screen. There's an identity. So fluxctl identity command. And maybe I should type this correctly. Fluxctl identity. Then he says, oh, wait a moment, I don't find it. What namespace are you using? Well, they use this funny parameter here, which is way too long. Okay, call it, it's the Flux CD namespace. And what do you get? Well, actually, when you deploy Flux and you didn't provide it with a key pair, private public key pair, it will generate a private public key pair for itself. And with this, you can actually you can show a public key. This public key can be added to your Git repo as a deploy key, and that's how you link up these two effectively. So I'm going to my settings of my repository. I'm going to the deploy keys, and you can look at the deploy key. It will be destroyed quite quickly when this video is online, so there's no cannot really use it for any reason. So demo clue, paste it, and also allow write access. That means that Flux can also write back to our repository. That's needed in some cases. I won't discuss that case in this video. Maybe in a later video I will do that. But for now I'm just giving it write access. I click add key, confirm my GitHub password, and that's done, right? So now we have this configured. If you look at Flux CTL, we can actually use the sync command to synchronize it with a Git repository now, but I think is already busy with it. So we're gonna switch to the namespace, which is default, and you'll see all kinds of things are being installed. In a moment we'll see what that is. So get po, and there you see there's a real-time application running, or a pod running. There's a Redis container running. There's also a HTTP solver running, which is going to be used for or by cert manager. We'll discuss in a moment what's going on there. So I basically let it do its thing, and if I'm going further, you'll probably see also another container coming up, which is InfluxDB. It's all coming from the configuration files in the Git repository, right? So I just let it do its thing, and we'll see how far we get here. Now, let it run. We're gonna take a look at the code for real-time YAML. So this one here, real-time, it's a simple application I wrote myself once, which is a Go implementation of Socket.io. So it's a small web front end which is listening to updates on a Redis channel, and then actually puts them on the web page. It's nothing important actually. It's just a demo app. Now that application requires Redis. So here in the YAML file, we basically deploy a Redis container. There's nothing special about that. Redis container listening on port 6379, and it only listens within the cluster. So the Redis container, or the Redis application, there's a service in the cluster which is actually listening on port 6379. That means we can connect in the same namespace. We can just connect to Redis colon 6379 to make a connection to this Redis container, which is not using authentication and so on. Again, it's just for basic demo purposes. So that's our backend, so to speak, a simple Redis container. And now we have a deployment of the actual real-time application. Now the real-time application is a simple container that I built myself, and I called it Flux app, and then use some semantic versioning, saying this is version 1.0.0. Not that important right now, because I'm not going to discuss versioning and updating images at this point in time. We'll see that maybe in a later video. But this is all basic YAML, right? And things are missing as well. Like, for example, readiness checks and stuff like that, they're missing. I just want to get these things up and running. So very simple, I'm saying I want a container called real-time based on this container image, but I have to configure the container image with some environment variables. What is the Redis host, for instance? Something I need. The container is listening on port 8080, and then we're creating a service for the real-time container. That one indeed is going to listen on port 80 and going to connect back to 8080 on the container. So we have a service, a real-time service in Kubernetes, listening on port 80 for requests. That one we actually want to publish to the internet, right? And we do that with our deployed ingress controller. So we have the Nginx ingress controller deployed. What we're doing is the following. We're actually saying, okay, we create an ingress, give it a name, we annotate it. It's not really necessary because there's only one ingress controller running here, but we say, okay, ingress class is Nginx. And then, and that's quite important, I also want to issue a certificate by the Let's Encrypt production issuer. And in a moment I'm going to show you how that is configured, because that's cert manager coming into action here, right? Also here I'm saying, look, you have to create, if there's no certificate available, you have to create one and make sure it's available for this application to use. Yeah, that works hand in hand with the spec here at the TLS level, where we're saying, yes, we want to host real.baker.info, and the secret with a certificate in it for this host should be this, right? And so let's encrypt, Cert Manager will make sure there's a secret like that available that contains, hopefully, a valid Let's Encrypt certificate. By the way, we also specify the name real.baker.info here, which also means, because of the installation of external DNS, that external DNS will see that you want to have a hostname of real.baker.info. It will create an A record in your configured DNS zone with the IP address that matches the incoming requests for your Nginx controller. So the Nginx pod is that the IP address of the Nginx pod is used for this A address. So this, all of this here, this single thing, this single ingress with the annotation we have here and the fact we're asking for a specific host is making sure that external DNS is creating the record, and is also making sure that Cert Manager is getting a certificate to actually apply to this application. Yeah. Now, it can take a while for the certificate to be issued. It all depends a bit on the order in which these YAML files are deployed. But there's one thing which is crucial for the certificate to be issued. We need to have this issuer instantiated correctly. Yeah, and the issuers are configuration as well. Here you see it in certs. I put a cluster issuer prod YAML, and you see it here. The name is Let's Encrypt prod. That's what we actually refer to in our ingress. And in this case, yeah, we need to follow some rules here. We're saying, well, yes, we're going to use the Let's Encrypt production issuer. You have to specify a user as well. Okay, that user does not will get maybe very annoying emails about this, but that's maybe not good practice. But okay, my name, in reality, my name should be filled in there. And the challenger we're using is HTTP, because of course Let's Encrypt has to verify that you are the owner of the resource you want to actually get a certificate for. What the system is doing is creating a very small HTTP server that contains some configuration that Let's Encrypt expects. It connects to that one. If it matches, he will actually issue a certificate. If that doesn't work, if there's something wrong with the HTTP challenger, you won't get a certificate, and of course that will fail. Now let's take a look at what is going on here. First of all, where's our ingress? So we're actually here in the namespace default get ing, the ingress, and we're looking. He said, here real-time ingress. That's this host, this address. Hopefully my DNS has been changed already by external DNS, and indeed the DNS record was updated. So my record at Cloudflare has been updated to point to the address of the ingress. That's perfect already. And you can see that the ingress is using port 80 and port 443. That's great. The question, of course, is, did we get our certificate? Okay, get cert. Yes. We have a certificate because it says ready to. So we have a certificate here. We can actually describe the certificate. So if we do that, I'll just type it for once instead of copying and pasting it. If we describe that certificate, he says, yeah, look, I created a new private key for you. I created a request, and the request was successful. Certificate was issued successfully. Wow, that's perfect. Let's see what the request was. Get certificate request. That's the request. Let's describe certificate request. Describe CR, and then copy and paste it for now because that's too long. I'm not gonna do it. And maybe I should type describe. And there you see, yeah. Well, this happens quite a lot. Sometimes he said, because actually that can happen, because the the actual certificate is requested before my issuers get deployed by Flux. That's just random how that works. Yeah, in the beginning the issuer was not ready, so that took a while before the issuer got ready. And then when the issuer was ready, he could then actually ask for a certificate, right? You can see here some more information about certificate signing request, the actual certificate that you get back, etc. Yeah. Yeah, there's also a concept of orders. So if you do k get order, that's an order to get a certificate from Let's Encrypt. I won't go into details there. And you will also, in the end, you will get a secret that contains the actual certificate. You see it there. So k get secret, and we look at what's inside the secret, and maybe we do OYAML, and there you see all kinds of stuff. Here is the certificate, here is the key, quickly write it down, and then some metadata, because somebody created this here. Who created it? Cert manager created it. He created it for real.baka.info. That's certificate name, the common name. Issuer is a cluster issuer for Let's Encrypt production. So you know exactly where this came from, this secret. But this also means that this secret, this is the one that our Ingress was referring to. So with all of this in place, we should be able to go to https real.baka.info. Let's see. There's the application, and let's check the certificate. And indeed, actually this is the older one, I think. So I'm going to, I think there's some caching going on. Or I got, yeah, indeed. So there was some caching going on there from yesterday. So this is the one from today. Yeah, it's the 9th of December. So this one got issued today by Let's Encrypt. It's a fully valid certificate because it's issued by the production issuer of Let's Encrypt. Now, not much is happening to the application because there is no Redis content happening here. So let's take a look if we can actually go there. So k exec -it. Let's connect to the Redis pod just for fun. Let's connect to it. I think it's bin sh. You have to do, yeah, here we are. Let's start the Redis. Is it that CLI? Yes. And then we have to, what was it? Publish. Yeah, to the channel. I think it's device 01. Yeah, it's hard coded in the HTML. And I'm just saying hello. So I publish this. Let's take a look. Yes, indeed. So it's listening properly on the internal Redis address on the cluster, listening properly to updates, and when such an update appears, using the socket.io, that's a library, he's showing these in real time in the browser. So the application, which is really a basic application, is working properly, and my certificate configuration is also working properly here, right? Now, using this system is not just for applications. Of course, every kind of configuration can be done. For example, you might want to configure your Azure Monitor configuration. The Azure Monitor configuration, for instance, that's something which is done with a config map. So if you want to put a config map on the system that configures, in this case, the Azure Monitor agents running on our clusters, you can do so as well. What I did here, for instance, was, if you look closely to where we are, where are we here? Yes, so we have a Prometheus data collection settings cluster, and there I provide the URL of scraping endpoints. So if you know a little bit about Prometheus, it's scraping metrics from an endpoint in your cluster. I enabled Prometheus metrics on my Nginx ingress controller by configuring this here. The Azure Monitor agents on the cluster will actually connect to that endpoint, get the metrics and drop the metrics in log analytics. So not in Prometheus, but in log analytics. So this is the Prometheus support that Microsoft has brought to the cluster. So this is a configuration file that you can drop on your cluster. Just any configuration will do basically. And if you look at that, if you go to the, I will exit this and exit it, yes, yeah. If you go to the namespace, KNS Cube system, where the OMS pods are running, you'll see that the OMS agents have been restarted, and that's because they got this configuration applied, right? So that basically means that if we go to log analytics, so let's try and do that. We go to log analytics, which is here, logs. Yeah, you can then actually get or run a query, and I'm going to quickly see what this query should be. Yeah, I wrote it down somewhere because to be honest, I'm not that great in KQL yet. It's also not as easy if you come from Prometheus. It's not always easy to have the corresponding queries for what you want to do. Let's see where it is. Yeah. So for instance, yeah. So what you should do is the following thing. So we want insights metrics. So we go to insights metrics. That's what we want. And you actually ask for events where the namespace equals Prometheus. Yeah, yeah. And if you do that, you get them all. So if you click on run, you'll see all kinds of metrics coming from that scraping endpoint. And indeed, what you see here is some Go metrics and some Nginx metrics. I can click on this, for instance. I can go to this one here, response duration seconds. Click on that, and I get some information about that, right? Now, of course, to get meaningful data out of this, you will have to write correct queries and then nicely display them in charts and so on. That's beyond the scope of this video, but you have seen that indeed by pushing this configuration using Flux, you get this consistent configuration of your clusters, the way you want it, basically, right? Good. So that's wrapping up this video. So I hope you have seen that by connecting the cluster we deployed to the Git repository, it is not very difficult to just put all kinds of YAML files, as you know and love, or maybe hate, to configure your Kubernetes cluster. You drop them into that Git repository, and it gets configured accordingly. For me now, it's very easy to go to this repository. So if I'm going to GitHub Gebake again, and I'm showing where is it? Yeah, this one. I can easily add additional config files to this to configure my cluster accordingly, right? And every time I destroy and create my cluster and configure the identity or the deploy key with Flux CTL identity, then everything gets configured. Now, that's something I will also automate, because it's a bit annoying to always have to do Flux CTL identity before your demo. But okay, I didn't do that now at this instance. Now, be aware, in my case, I also have an action coupled to this repository, an action that validates the YAML files. So whenever I add YAML files, I have to do a pull request, and on the pull request, he's going to actually check if my YAML files are okay. That most of the YAML files are okay, because I'm skipping the ones that have missing schemas. And I do have some kind of, let's say, verification, like, okay, real-time YAML, it's a valid deployment and a valid service and a valid ingress. But again, that's beyond the scope of this video. That also makes it a little bit, yeah, let's say a little bit more robust, that you do some checking of your YAML file before you actually commit to master. Okay, that's it. Thanks for watching, and see you in another video